Okay, another set of prerequisite skills that you need to have in this particular class is to be able to deal with finding missing sides of your two special right triangles. They are the 30-60-90 and the 45-45-90. What I'm going to do is a derivation of why the relationship is what it is for those two particular triangles. So what I'm going to do is start with a square. By definition, all four sides of a square are equal. Forgot to draw those in. All four angles are right angles. And then what I'm going to do is draw a diagonal in. Now, due to the symmetry of a square, that diagonal breaks the two right triangles, or two right angles, into 45 degrees. So what I'm going to do is I'm going to pull that right triangle, which is a 45, 45, 90, away from the square so it's less distracting. Now, we didn't say how long each side of the square was. So what I'm going to do is just let it be x. Okay, so that means that that guy is an x and that guy is an x. Now we know from our other prerequisite worksheet that we can get an expression for this third side by using the Pythagorean theorem. So I'm just going to let this be c for now because it's the hypotenuse. X squared plus x squared is equal to c squared. 2x squared is equal to c squared. Square root both sides. C represents the length of a triangle, so I can throw away the negative root. We just need a positive root. That can come to the outside, and we get x root 2. So what we have is a right triangle. Its three angles being 45, 45, 90. If we let one of the legs be x, the other one must be x. That makes the hypotenuse x root 2. All right, as it appears on the SAT formula card or formula page, they use s and s root 2. This is considered knowledge you're expected to have for the purpose of the SATs. It's also on the ACTs. The ACTs do not give you the formula, though. And part of what you need to know for the beginning of this particular class. All right. The derivation for our other special right triangle. What I'm going to do is start with an equilateral, equiangular triangle. Equilateral means that all three sides have the same length. Equiangular means all three angles have the same measure. Well, we know that the sum of the three angles of a triangle, 180 degrees, so if all three angles are the same, each one must be 60. Similar to what I did for the previous demonstration, or derivation, I'm going to split it in half this way. I'm going to split it in half, but in a different way than the square was. So due to the symmetry issues, we know that that's going to be 30, that's going to be 30, and that'll be a right angle. So I'm going to pull this out, get rid of the extra stuff that we don't need to see. Now with the square, what I did was I let the side that was unknown length be x. Now I can go through this derivation with that unknown side being x, but it doesn't quite match the formula bar as it appears in the SAT. It doesn't quite match the way that you've learned it in geometry, and it's a little bit cumbersome to work with. I can call this whatever I want. To make the end product a little bit nicer, I'm going to call it 2x. Okay, now if that's 2x, this has to be x. And that goes back to the symmetry thing we had before. When we draw in that line of symmetry in the middle, it cuts that in half, making these two things congruent. So if the whole thing was 2x, then each one of those would be x and x. So what we need is an expression for that other side right there. So I'm going to just call it b for now. So x squared plus that b squared equals 2x quantity squared. Our goal is we want to get an expression for b in terms of x. X squared plus b squared is equal to 4x squared. Get this over here. B squared is equal to 3x squared. Square root both sides. We can discount the negative root because it doesn't make sense in the context of this problem. That can come out, and we get x root 3. So in summary, the relationship between the three sides of a 30, 60, 90 triangle. The nice one, in terms of the easiest work to be done, is if you know the shortest side, which is the side across from the 30, that's what our x is. Whatever that is, you're doubling it to get the hypotenuse. Whatever that is, you're multiplying it by root 3 to get the middle side, which is across from the middle angle, which is the 60 degrees. So as it appears in terms of orientation on SAT formula page, you see the side across from the 30 is your x, the hypotenuse is the 2x, and the side across from the 60 is the x root 3. Now, as far as this class goes, you are not responsible for the derivation of those two triangles. The reason why I do things like those derivations with you is once you get into some upper level math classes in college, especially if you're going to be a math major, an engineer, a hard science type of major, the focus of the classes moves away from can you use a formula to can you prove this formula? Can you rewrite this formula? What else does the formula work for? So the going through these types of derivations, although it's not something you're typically going to be responsible for in this class, it is something that you will be responsible for in the very near future for those of you that are going on to mathematically intensive majors in college. Also linked on the same page that you'll find this video is going to be another video that will run through some numerical examples of using these formulas. So make sure that in addition to watching this video, you watch the other video that's associated and linked on the same page.